You have tremendous control, and even after you get cancer, you have control. We have control on both ends, both the prevention and the management. We can control this because we understand what the nature of the disease is.
So why do people get cancer?
Well, there's a lot of things. We call them risk factors. There are a lot of risk factors that will impact how cells produce energy. And you get cancer by damaging the ability of a cell in your body to generate energy using oxygen. How that comes about could be any one of a number of different, what we call secondary risk factors. The primary risk factor to cancer is damage to the respiratory capacity of the cell to generate energy using oxygen. Okay, so that could be due to chemical carcinogens, exposure to chronic exposure to chemical carcinogens, exposure to radiation, chronic inflammation, intermittent hypoxia, rare inherited mutations, just getting older, oncogenic viruses. There are certain kinds of cancer-causing viruses. Any one of these secondary factors has the potential to damage respiration in a cell of our body, causing that cell to lose its growth control and become a cancer. So was called the oncogenic paradox. In other words, how is it possible that we can have so many different things? Like if a person, two or three people have breast cancer, they all have what would be called clinical breast cancer, but the origin for each person may have been different, but the outcome is very, very similar. And you could say that for lung cancer, colon cancer, bladder cancer. Someone is diagnosed with bladder cancer. Okay, you got bladder cancer. It's stage 1, 2, 3, or 4. Okay, but one person may have gotten bladder cancer from exposure to chemical carcinogens. Another person may have gotten bladder cancer from chronic smoking or something like this. The end result is that there were cells damaged in the bladder that caused a dysregulation of cell growth, usually a chronic disruption of respiration, leading to a dysregulated growth in that cell of that organ. But you can pick any organ, a prostate, a breast, a liver, a lung, a brain, colon, stomach, whatever it is. The origin is similar in the fact that the respiration would have been damaged in a cell from any number of provocative agents that could have been there.
Wow. So for a given cancer, there are many roads to developing that cancer, but they all kind of somewhere along that journey, there is damage to the respiratory capacity of the cell.
That's correct. And that cell then loses its growth control. And the definition of cancer is cell growth out of control.
A lot of people, I think, believe that there's a strong genetic component to this. But I've heard you argue that cancer is largely metabolic in origin. Unpack that for us. What's the difference, and what role do genes play?
Well, you have two kinds of genetic problems. One is in the germline. You can inherit a gene that would increase your risk for cancer, like the BRCA1 mutation that you hear about with women who have breast cancer. So that's an inherited gene you pass down from one family member to the other, to another family member. It's in the germline. You inherit it. Women with that mutation have about a 50 to 55% chance of developing breast cancer, but not 100%. So that means it's a secondary risk factor. It's not a primary risk factor. The person who gets breast cancer, who inherits the BRCA1 and gets breast cancer, the tumor cells in that person's breasts have defective oxidative respiration. So why the mutation that you inherited causes dysfunctional respiration in one person and not in another person with the same mutation is not clear. So In other words, because if the mutation were 100% penetrant, meaning that every woman that would inherit that mutation would absolutely develop breast cancer at some point in her life, then that mutation would be considered the primary cause of the disorder. The fact that not everyone that inherits the mutation will develop the phenotype, which is breast cancer, means that it's a secondary cause. But every woman that does develop the cancer from that mutation has damage to respiration in the cells of the tumor. So clearly, the mutation damaged the people who have breast cancer. The people who have the mutation and develop breast cancer, those people, the mutation damaged their respiration. Why another woman with the same mutation didn't damage her respiration, we're not really clear. So that's germline mutation. The somatic mutation theory of cancer says that the cancer cells collect mutations from any number of places, and it's the mutations, those somatic mutations, they're not inherited. They're acquired by lifestyle and just living on the planet. Those cancer cells have large numbers of somatic mutations. These are non-germline mutations. And people say, oh, every tumor we look at, we see all these somatic mutations. Therefore, the somatic mutations must be responsible for the dysregulated cell growth. And the answer is no. Those somatic mutations are downstream effects of the damage to the respiration. So the damage to the respiration is number one. That's the origin of cancer. The damage to the respiration produces radical molecules called ROS, reactive oxygen species. They are carcinogenic and mutagenic. So the mutations you see in cells of cancer in the tissue itself are downstream effects of the damage to the respiration. Everything comes back to the damage to the respiration.
So if I'm understanding correctly, so all cancers are due to some interaction between these genetic risk factors and the environment. And along the sort of the genetic risk factor chain, there's sort of a bifurcation where you get germline mutations and then you get these somatic mutations. The germline mutations are present at birth, and the somatic mutations are essentially also influenced by the environment.
Yeah, well, the environment is that now we're finding that a lot of normal, like for example, you look like a young, healthy guy. If we were to take a chunk of your tissue, liver, kidney, or something like that, you don't have cancer, right? You're healthy?
Correct.
Okay. So if we were to take a chunk of your tissue and analyze the genetics in the nucleus of your tissue, we would find cancer-causing what they call driver mutations. And you'd say, well, how the hell? The somatic driver mutations are supposed to cause cancer. How is it possible that I have driver mutations in my liver and kidney and spleen and I don't have cancer? So the people who think cancer is a genetic disease never address that fact. They never discuss this. We've done so many different studies, and we find all kinds of discrepancies with the somatic mutation theory. You have to be cognitively challenged or an ideologue. And that's what the problem is. The people who are running the cancer programs are either cognitively challenged or they're dogmatic ideologues. And when you have that view, no matter what I say, no matter all the evidence that I present to the contrary, it cannot be accepted, period.
So what is the prevailing dogma currently, that cancer is...
It's a genetic disease. If you go to the National Cancer Institute website, the first thing you see, what is cancer? Cancer is a genetic disease. So I just told you I have massive evidence to say it can't be a genetic disease. You have to be cognitively impaired to think it's genetic because you don't look at the data that says it can't be a genetic disease. Like I said, the mutations come as downstream effect. They're effects. They're not the cause. We're not saying there's no mutations in cancer. There's plenty of mutations. The problem is they're the effects. They're not the cause of cancer. So we take that nucleus full of mutations and put it in a new cytoplasm. The cell is growth regulated because the respiration in the cell is regulated. So clearly, the nuclear mutations are not the cause of the cancer.
So does that suggest that we have, according to your studies, a significant amount of control when it comes to whether or not we are to develop cancer in our lifetimes?
That's absolutely true. You have tremendous control, and even after you get cancer, you have control. So we have control on both ends, both the prevention and the management. We can control this because we understand what the nature of the disease is. We understand that if every cancer cell, when you have defective respiration, you're taking away the prime energy for this cell, yet the cell is still alive. So you say, how is it possible if the cell can't get energy from oxygen, yet it still makes energy and it still divides? So there's energy there, but it's not coming from oxygen-related energy. It's coming from ancient pathways called fermentation pathways. These are energy without oxygen. And as I tell everybody, all the cells that existed 2.5 billion years ago on our planet got energy without oxygen. So they were fermenting energy there. And you say, oh, okay. That's really interesting. So the cancer cells are getting energy without oxygen. Well, okay, how do they do that? They do that with the process called fermentation. Well, what's fermentation? Fermentation is energy without oxygen. Well, what's the fuel? Where you get the? Okay, so you say, well, it's got to be a fermentable fuel. So what do we know in our bodies that can be fermented to generate energy without oxygen? And the answer is sugar, glucose. You can generate energy from glucose without oxygen through the fermentation. Like, for example, if you do a sprint and you run very, very fast, your muscles create so much, the demand for oxygen the muscles need so much oxygen, but they can't get it, so they start fermenting. They start producing energy without oxygen. But that's only transient. As soon as you start breathing again, the muscle cells go back to respiration using oxygen. The cancer cell is locked into a fermentation mechanism. It cannot use oxygen even if oxygen is present. So it's locked into this fermentation. And the drivers of this are the sugar glucose and the amino acid glutamine. Those are the only two major fuels that will drive the fermentation of the cancer cell. So you say to yourself, wow, then if we take away the two fuels, the cancer cells should die. And the answer is yes, they do die. So the question is, how come the pharmaceutical, how come the NCI and National Cancer Institute, how come all the funders of cancer research don't know about this? And the answer is, I don't know. If they have any functional brain cells, they should be able to figure this out real quick. And I'm saying to myself, how is it possible that and a lot of scientists do know this, but you become locked into an ideological dogma and you can't get out of it, no matter what anybody tells you. So the solution to the cancer problem is not that difficult, and all the tumors have the same or very similar problem. So everybody says, oh, it's so complicated. Yeah, if you're looking at the wrong thing, you're looking at downstream effects. Everything looks complicated, but it's not that complicated.
Does dietary sugar fuel cancer cells?
Let's put it this way. We did a number of studies. Okay, and these studies in mice were replicated in humans with all kinds of cancers. What we found is that the higher the blood sugar in the mouse's system, a cancer-bearing mouse, a mouse with a tumor, the faster the tumor grew. Okay, the lower the blood sugar, the slower the tumor grew. This is what we documented using linear regression analysis, using large numbers of mice. So what about humans? So they said, yeah, maybe, let's double check it. So what we found in glial brain cancer, the higher the sugar level in the patient with the brain tumor, the shorter was their life. Their overall survival was lower. The higher the sugar in the woman with breast cancer, the faster and more metastatic the breast cancer was. Wow. So clearly, there's a direct linkage between how high your blood sugar is and how fast the tumor in your body will grow.
Well, we're seeing staggering rates today of metabolic disease, right? 9 in 10 adults have some component of the metabolic syndrome. 1 in 2 adults are now trending towards obesity, and about half of the population has prediabetes or type 2 diabetes, which is characterized by chronically high levels of blood sugar. Are we seeing rates of cancer increase lockstep with these other comorbidities?
Yeah, absolutely. Obesity has now replaced smoking as a major risk factor for cancer.
Wow.
So type 2, in fact, when we see most of the patients in my colleagues that have clinics, so many of these people are metabolically out of whack. They have all kinds of metabolic problems, type 2 diabetes, obesity, all kinds of blood work disorders. I mean, we're eating ourselves to death, bottom line. And you get diabetes, you get cancer, you get cardiovascular disease, macular degeneration. You can go right down the list of chronic diseases. And it's all because of the diet and lifestyle. We're eating massive amounts of highly processed carbohydrates. We're not exercising nearly enough. And we're just eating bad food with a poor lifestyle. And we're blaming it on everybody. We're blaming it on the federal government. We're blaming it on the pharmaceutical industries. And we should be blaming ourselves. They're there to make a profit on our poor behaviors. It's not right. It makes sense, right?
Barely. No, none at all. It's shocking. But so is the solution then that everybody could we potentially eradicate cancer if were everybody to adopt low carbohydrate diets, or is it more I'm assuming it's more complicated than that.
Yeah, well, we can do it on a mouse. They have no choice. They're choiceless. We put them in a cage and we fast them and keep them on a low carbohydrate restricted diet. And even mouse strains that would normally develop, 50% of the mice would get cancer just by eating the lab chow. We put them on a calorie restricted. Others have done that. Tannenbaum and his research had done that. The rate of breast cancer in the DBA strain of mouse went down 95%. So
Wow.
clearly you can control. But the problem is when you say that, oh yeah, it sounds great, and then you go buy a Subway sandwich or Taco Bell and you pound down this kind of stuff, and it tastes so good. And it's hard not to eat the very foods that are putting us at risk for cancer and type 2 diabetes and dementia. It's another one. Let's throw Alzheimer's in the pot. That's another consequence of bad diet. Alzheimer's disease. Yes, there's a genetic component to Alzheimer's, but a lot of it has to do with diet and lifestyle.
So yeah, similarly to Alzheimer's or to cancer, Alzheimer's disease, we have these known genetic risk factors, but genes are not destiny. Particularly,
no. You got to be careful. In Alzheimer's disease, there are some genes that are destiny. There are a few genes. They're rare. They're about 5% of people with Alzheimer's disease inherit a presenilin mutation, and if fait accompli, you're going to get Alzheimer's disease. Huntington's disease is another neurodegenerative disease where the mutation in Huntington, 100% everybody who has that mutation develops Huntington's disease. So there are some mutations that are the prime cause of the problem. But in Alzheimer's disease, you do have rare inherited mutations that are like 99% penetrant. So if you have that mutation, there's a real chance you're going to develop Alzheimer's disease. But a good 55 to 65% of people with Alzheimer's put that on themselves by the diet and lifestyle that they have.
Yeah, you're describing early onset familial Alzheimer's disease, right? Which was
yes. Those kinds are probably minimally modified by diet and lifestyle.
But again, the vast majority of cases, late onset sporadic Alzheimer's disease, generally very responsive to or potentially preventable.
I think you can say more preventable if you knew. Right. If you knew in advance that you would have a risk factor for, like, you can have a genetic risk factor, but that genetic risk factor works together with the environment that you're in. So you might be able to modify the environment so the risk factor does not become a major facilitator of developing the disease. In cancer, normally humans don't get cancer. Cancer in Aboriginal tribes of people was very, very rare. Those folks, physicians and scientists that study Aboriginal peoples, always remarked in all their findings that cancer does not exist in Inuits. Cancer does not exist in Australian Aborigines. Cancer does not exist in certain African tribes or rainforest people. So what the hell happened? The poor Inuits today they have like 50% of their population is diabetic. They have huge numbers of cancer. It's all from the food that the Western diet and lifestyle screwed these people up terrible. I mean, their bodies were so lean and mean. You eat a specific kind of a seal or a whale or a fish, and you eat that and you never get cancer. Then all of a sudden you're pounding down Big Macs and Subway sandwiches, and the next thing you know, you got all kinds of diseases. It's not a complicated problem here.
Yeah, no, where the Western diet goes, disease soon follows. I mean, that seems abundantly clear at this point. So, are there analogs in cancer to that early onset familial Alzheimer's disease that are 100% deterministically, causally related to a gene mutation?
Yeah, well, no, we haven't. We looked at every one of the major genes, and none of them are 100% penetrant. The highest one is Li-Fraumeni, the Li-Fraumeni cancer syndrome. It's a mutation in the p53 gene in the mitochondria. It's about an 85 to 87% penetrant. So that means about 13% of the people that have that gene never develop the tumor. But it's a very strong inherited risk factor for that particular type of cancer. But because it's not 100% penetrant, it can't be considered a prime cause. It's a secondary cause. The issue, of course, is that it's damaging the very organelle responsible for generating energy through respiration. So the mutation is actually damaging the organelle needed for using oxygen for energy. So the penetrance is higher for that than it would be for, say, another type of. Some of these inherited mutations are like 12 to 14% penetrant, meaning that 85% of the people that have the mutation, they're not going to get cancer. So again, you always have to look back and say, is the risk factor a primary cause or a secondary cause? And primary cause is, in other words, every time you see that defect, you have everybody that has that defect has the phenotype, the condition. And in cancer, every cancer has a defect in oxygen respiration. So we know that's the primary cause. And that's what Otto Warburg said back in the last century. He said the primary cause of cancer is the defect of respiration followed by compensatory fermentation. And that's exactly what our research has proven, that Otto Warburg in large part was correct on describing the origin of cancer. Problem with Warburg, he never morphed that into a therapeutic strategy to treat patients in the clinic, but he defined what the nature of the disease was. He just didn't exploit it for managing cancer.
I've heard of the Warburg effect, which is obviously named after him. What is that? Can you describe that for us?
Yeah, well, it's the use of continued production of fermentation waste product, which is lactic acid. When you take in glucose, see, if you take in glucose in your body, like, I'm not saying glucose doesn't cause cancer. Glucose is a facilitator of tumor growth if you were to have cancer. High levels of glucose create systemic inflammation. Inflammation damages respiration in the cell. The Warburg effect is the continued use of fermentation continued fermentation with lactic acid production in the presence of oxygen. So why does the cancer cell continue to ferment and produce lactic acid in the presence of oxygen? Because its respiration is damaged or deficient. And the damage to the deficiency is in the structure of the cell called the mitochondrion. The mitochondrion is an organelle inside the cell that generates the energy that we need for the function of those cells, the function of our body. Cancer cells have defects in that organelle, leading to a fermentation. And when the fermentation replaces the use of oxygen, the cell loses its growth control and grows dysregulated. And the organelle that controls the stable differentiated state is that organelle, the mitochondrion. So when it gets damaged or deficient, the cell starts to go back to its default state, the way it was 2.5 billion years ago. And as long as there's fermentable fuels for that cell, it's going to continue to grow.
Fascinating. So glucose doesn't cause cancer per se, although when it's chronically elevated, it can lead to the damage that will ultimately cause cancer. But once you have cancer, it feeds those cells.
Yeah, it definitely feeds the cells. And the oncogenes, it's interesting, when the mitochondria becomes defective, and if like Warburg said, if it's too acute, the cell will die because the cell has no way to adapt to the restriction of energy. But cancer doesn't happen overnight. You don't go to bed clean and then wake up with a big tumor on your ass the next day, right? It takes a long time for this process, for the cell to adjust and adapt to the inability to generate energy from oxygen. So, and then the cell falls back on this fermentation mechanism, leading to dysregulated cell growth. But that process takes a long time. You really have to abuse your body for many, many years to force this condition to happen. Because, as I said, the Aboriginal peoples, they never got cancer because they never abused their body for 35 years eating crap food, and doing shit. So it's hard for a human. Our bodies are so resistant to cancer. It's absolutely incredible. I mean, the fact that we have so much cancer tells us that we have played a major role in body abuse. I mean, it's just.
Yeah. Yeah. No, I mean, it's absurd that we're seeing such startling rates.
Yeah.
Some have said that that just living longer, like if we push human lifespan long enough, we're all inevitably going to develop cancer. Is there any truth to that?
Well, I don't know. We have a lot of centurions that live into their hundreds. They die from old age. They never got cancer. So, I mean, I don't think that's the case. Okay, cancer is just a symptom of damaged respiration. So if you keep your respiration healthy, the probability of getting cancer is significantly reduced. The risk of getting cancer is significantly reduced. Now, we have an intrinsic set point in our bodies that allow us to live a certain number of years on the planet. Every species of animal has a lifespan. That lifespan seems to be dictated by some intrinsic property of the mitochondria. The mitochondria, if you live long enough, say into your 90s, people die. And you say, what did he die from? Well, he was old. I mean, a guy, what the hell? He's 96 years old. Like Queen Elizabeth. Oh, she's alive one day shaking the hand of the prime minister. The next day she's dead. I mean, but she died from old age. I mean, she died from what we call a systemic shutdown of mitochondrial energy within the body. So it's a systemic shutdown. But if you damage your body through lifestyle choices, your body is, here it comes down to the second law of thermodynamics, which is entropy, disorder. We all have to deal with entropy. Maintaining order and energy efficiency is what the mitochondria in our body does. So healthy mitochondria maintain order and discipline within the cells. Living on the planet years and decades wears down on those organelles, and by entropy, the second law of thermodynamics, they eventually lose their capacity to maintain the differentiated state, and you die from old age. Cancer is accelerated entropy. So what you have now is disordered cells, but they're growing out of control using a fermentation mechanism. And that ends up causing more entropy and ends up killing you. Now, of course, the treatments that we use, toxic chemicals and radiation and all this kind of crazy stuff, that just knocks the crap out of your body. So you're taking all your healthy cells now are being significantly damaged by the treatments to stop the proliferative growth of the tumor cells, right? So these tumor cells are growing out of control. So now we need to poison the patient to kill the proliferating tumor cells, but knocking the crap out of our normal system in order to kill a few. Those tumor cells can't grow without glucose and glutamine. So and if they can't burn fatty acids or ketones, the fatty acids and ketones make our normal cells very, very healthy. So we target the fermentable fuels while raising the ketones in our body to keep the rest of the cells super healthy. And then we can slowly degrade the cancer without toxicity to the rest of the body. What I just told you is incomprehensible by 99% of the people in the cancer field. They just, either they don't know about it, they don't want to know about it, or they can't understand it. And that's the question. That's the question. Why can't people understand? I think they definitely can understand it. Problem is, God forbid they do it. What happens if you do something like that? I mean, all of a sudden these people are not, and not only do you get rid of your cancer, you get rid of your type 2 diabetes, cardiovascular disease at the same time. Oh my God. Oh, no. Can't do that, man. Cannot do that.
Well, there's just not as much money to be made from people that are healthy.
Then it's another issue. Okay, then let's bring it back to the real issue. What's the real issue? Hey, we got to we all listen.
we all got to pay our rent, but it's unfortunate.
Yeah. Oh, you got care. Well, that's your personal misfortune.
Yeah.
I mean, but you're a cash cow for the industry, and and they're just trying to. You did that to yourself, basically, and now we're going to come in with this kind of treatments.
Yeah.
So we're all responsible for our own destiny, in a way.
So when it comes to prevention and managing, I do want to talk about glutamate, the other fuel that you mentioned.
No, glutamine.
Yeah. The amino acid glutamine. But when it comes to managing glucose, there's there's our postprandial blood sugar. A lot of people these days are, they're wearing continuous glucose monitors, and there's, some have argued that we really have to mitigate these blood sugar spikes. But then, of course, there's also there's something different, and that is the chronically elevated glucose that you see in the setting of type 2 diabetes, right? The fasting blood sugar that's chronically elevated.
Right.
So how do we manage our glucose? I mean, is it, again, do we all need to be on low carbohydrate diets, or is this ultimately, the concern about fasting blood sugar, which can be mitigated ultimately by a diet that doesn't necessarily exclude carbohydrates, but just keeps you in a state of energy balance?
Yeah, I think so. I mean, I think we have to blend. We're not going to go back and live like we did in the Paleolithic period, but we certainly have to be aware of, we built the glucose ketone index calculator, the GKI index, for cancer patients, basically so you knew if you had cancer, you knew how far you could push your blood sugars down and how high you get your ketones up, putting maximum pressure on the survival of the tumor cells. But a lot of folks took that, and healthy guys like you, young, healthy people, they're out there looking at their glucose ketone index saying, wow, look how low I got my GKI. It means that my mitochondria are going to be humming with energy efficiency. And that's true. But for the cancer patient, we need to bring the glucose ketone index down to kill the tumor cell. But at the same time, the elevation of the ketones makes our normal cells very, very healthy. Glucose is easily managed with diet and lifestyle. The glutamine issue is there's no diet that will target the glutamine. Glutamine is made by the body. Glutamine is an essential, and in some ways it's a very essential amino acid, necessary for our immune system, necessary for our gut, necessary for the urea cycle, but it's a fuel for cancer cells. Glutamine is not a risk factor for cancer, but if you have cancer, glutamine works with the glucose together, so they fuel together. So there's no diet that we can target glutamine. So we have to use specific drugs, and those drugs must be used with a great deal of sophistication, because if you're too aggressive in targeting glutamine, you're going to harm your gut. You're going to harm your immune system. You're going to harm your urea cycle. You're going to make things bad. So there's where the knowledge base has to come in. So you need to know. That's why we developed the press pulse therapeutic strategy for managed cancer. You can press glucose constantly down, because we don't need glucose. We can substitute ketones for glucose. So we don't need glucose. We absolutely need glutamine. But we know that our normal cells need it and the tumor cells need it. So what we can do is we challenge the glutamine just briefly. And what that does, when you have a chokehold on the glucose, you challenge the glutamine just briefly, slaughters a lot of tumor cells. But we pull the glutamine off and give the glutamine back to the patient. Now, what that does is it restores the power of our immune system to pick up the dead corpses of tumor cells. And then once there's a few tumor cells that survive as the result of this, but then we go back and hit them again, and we slowly degrade while keeping the rest of the body healthy. Man, this is so elegant. It's so based on evolutionary biology and normal physiological processes. So once you know how to balance all these different cells and organ systems together, You can get rid of a lot of these things. Does it require discipline? Absolutely. But the person is also in charge of running the show. So once you have the mental acuity to know what to do and how to do it, a lot of people like doing it. They're playing a role in their destiny. They're playing a role in the survival of their soul. So they're playing a role in managing themselves. And they keep log records, and they can say, oh, look at my glucose, my ketones. Now I can take this little thing here and that. And they work with trained professionals that know how to do this.
It's fascinating.
Makes sense, right?
Yeah, it makes total sense. I mean, a lot of people.
Not only makes sense, it's based on hard biochemical science as well.
It's amazing. Because, I know many people who are listening to this probably have been touched by cancer in some way. I know personally I have been touched by cancer in my family. What are some of these glutamine modulating drugs?
Well, they're coming on the market, but they're few and far between. And the pharmaceutical companies, in order to make profit on drugs, you've got to use the drug by itself compared to population not using the drug. So I got to use a glutamine inhibitor in these people, and then in these folks, we're not using the glutamine inhibitor. But it's like the horse. I mean, you're trying to corral the horse. If the back door is open, the horse is going to run out the back door. You got to target. You got to use glutamine when you're targeting glucose simultaneously.
Right.
The drug will not work really, really well. It will have some cancers that are metastatic will respond to glutamine targeting better than some other kinds of cancers that are fast growing but not metastatic. We've found cells. Some cells are more glutamine dependent than other cancer cells. Some cancer cells are more glucose dependent than glutamine dependent. See, we don't. If we hit both fuels simultaneously, we don't care. It'll kill them all. So
right.
There's no resourcing. Oh, they can shift to another fuel. No, they can't. We've interrogated these cells. These are the only two fuels that will drive the beast. So we need to shut both doors down simultaneously. So the pharmaceutical industry is coming out with all these new glutamine targeting drugs. The problem is a lot of them don't work effectively. We use dirty drug. A dirty drug in the pharmaceutical industry is something you don't really want to use because there's no specificity to it. So if you want to patent a drug, you have to have a very specific drug target interaction. When you have a dirty drug, like for example, the cell has many channels to get glutamine into the cell. There's a whole family of transporters. Then there's a whole family of enzymes that metabolize glutamine to glutamate. Now, we use a drug called 6-deoxynorleucine. It's a dirty drug. It blocks all of these pathways simultaneously, but you can't patent it because it's not specific. We don't care because we know that it'll help the life of the patient. So we're not interested in making a buck. We're interested in how long this patient can live. Problem is that drug was used years ago in cancer patients, little kids with cancer. It didn't work as well as we now know it can work because they weren't targeting the glucose at the same time they were using the drug. And therefore they had to give excess amounts of the drug, which led to toxicity. So people will say, oh, that glutamine Don drug is toxic. Compared to what? Radiation and chemo? Is not even comparable to the toxicity that many of the drugs we're using today. But if we know how to use it, we can bring the concentration down really low so there's no toxicity associated with it. And the power of the drug to target and do what it does increases dramatically. So, but we're not using it. I would say the patients need to go to their Congress for crying out loud. Get the doctors I want to give my patient 6-deoxynorleucine, but I can't get it. Where am I going to get it? And the answer is, why they should have it available. They got the Ozempic. Everybody's got sticking themselves with Ozempic, and that kind of crazy shit, what, so I can lose a few extra pounds? I mean, and wait until you see the long-term consequences of that.
Oh, yeah. And you
look good for a while. Then you start dreaming of movie stars, right? If you take the Ozempic.
Now they're starting to push this idea that obesity is genetic.
It's genetic because the genes that we evolved as a starved species. The genes are doing exactly what they evolved to do: store energy.
Exactly.
You keep your mouth shut; those genes are not going to be able to store energy. Why am I gaining so much weight? What are you eating?
Well, exactly. Because the way that Ozempic semaglutide works is it impacts hunger. It makes you less hungry. Yeah. It affects your appetite. So clearly, If you were just to eat less.
Yeah. How can you gain weight when you don't eat anything?
Exactly.
They want to blame the genes rather than the muscle that operates your jaw.
Oh my God.
It's crazy, right?
What a scam. Yeah. No, it's a problem. Okay. So one thing that I'm curious about, even when a person initiates a ketogenic diet, there's still a background level of glucose, right? Like the brain needs a certain amount of glucose to survive. So how is that? Does it not?
No. You got to look at that. You got to look at the paper by Drenick. Drenick did a nice study. He took 18 or 19 morbidly obese men, BMIs like over 30, and fasted them for 21 days. Okay, no food. Okay, so blood sugar goes down. Ketones go up 3 to 4 millimolar in the blood. Then we took these patients and injected them with a high dose of insulin. Brought glucose levels down to barely detectable levels, 0.5 millimolar, 9 milligrams. Anybody working in a ICU unit or any physician would say that person should be dead. No. They were walking around perfectly cognitive because the ketones were replacing glucose in the brain. So the brain can burn ketones or glucose. So you can push glucose levels down really, really low, as long as you're using ketones to replace the glucose.
But you would need a drug. You would need exogenous insulin to do that, right? Like your liver will create.
That just proves that the brain can burn and survive on ketones.
Got it.
Yes.
Okay.
But if you now listen, if you're in a diet that has very low glucose, well, okay, let's just bring it, like I said, 65 milligrams per deciliter, which is like 3.2 or something like that millimolar, which is very low. Now, the interesting thing is other cells in the body will upregulate transporters and facilitate, they become super insulin sensitive. So any molecules of glucose in there are going to be consumed by normal cells. Of course, normal cells, they use glucose, but they can use fatty acids and you can use ketones. So normal cells are extremely flexible. But if you lower blood sugar, the demand for glucose in all of the cells of our body is increased because of their insulin sensitivity. The tumor cell absolutely has to have that glucose. It can't live without the glucose. So now you're using the normal cells of your body and their demand for a fuel that they can use, but they're not absolutely dependent on it. Whereas the tumor cell is absolutely dependent on it. He becomes at a competitive disadvantage. He is now, for the tumor cell for the first time, is competing with the normal cells of the body for an essential metabolite. If you are pounding sugar all the time and you have very high blood sugar levels, the normal cells of our body they're using as much glucose as they can use. There's no competition for the fuel. So the tumor cell is fat and happy, growing like crazy because there's no competition. So this explains why you have these massive amounts of tumors growing fast through the patients. You got to know how to play the cells of one type off the cells of another type. You got to bring your body back into a new state of metabolic homeostasis. And the primitive tribes, the Paleolithic people, the Aboriginal people, they were always in ketosis. They always had very low glucose and they had ketones because they were not consuming carbohydrates. So if you're not consuming carbohydrates, you got to get your energy from ketones or fatty acids. Cancer cells cannot use ketones or fatty acids. They're dependent on glucose and glutamine. And glutamine is low. If you're fasting, glutamine can be low, and you're not going to get cancer. You're not going to damage respiration.
Fascinating. So it's simple supply and demand. So when you keep your blood sugar low, you're suddenly causing the tumor to compete with all the other cells in the body that want dibs, that have dibs on that glucose.
And the brain included. The brain included.
Got it. Yeah. So, and if you're not in ketosis, there's more than enough glucose to go around, and so the tumor cell is getting exactly what it needs to thrive.
Not complicated.
Not complicated. So how do we? Because one of the biggest problems for cancer patients is the risk of cachexia, right? Like dramatic muscle wasting. So like any kind of dietary modification for the cancer patient, I feel like is going to be potentially risky, is it not?
Well, cachexia is a pathological weight loss because the metastatic tumor cells, which we have defined as macrophage-like, they take in a lot of glutamine and they're grabbing the glutamine from the muscles. So the muscles kind of break down and you can fuel the tumor cell with the muscle breakdown.
Interesting.
Okay, so that's where cachexia comes in. So cachexia is a wasting condition. Even though you're eating food, your body is wasting away. Now, the very interesting thing is you have if you take chemotherapy, you lose weight. Well, everybody says, "Oh, I lost all this weight. I took chemo. Why? Well, I was vomiting. I had nausea." Nausea and vomiting is a great way to lose weight. You forget about Ozempic. Take some cisplatin. You're going to lose a hell of a lot of weight if you take cisplatin, which is a powerful cancer drug. You get sick as a dog. You have diarrhea. You have all this kind of stuff. Those are all indirect forms of calorie restriction. So you're cutting down calories. But poisonous chemicals, radiation will cause weight loss. Metastatic cancer cells will cause weight loss. All of these conditions are called pathological weight loss. It's pathological. If you go under water-only therapeutic fasting, you lose weight because you're not eating, but your body gets super healthy. So that's therapeutic weight loss. So yes, at the very beginning, there will be pathological weight loss overlapped on therapeutic weight loss. As you gradually kill off these tumor cells, the impetus for cachexia goes down. And then when the patient starts to eat, they will gain weight and become healthy again. So this is it's the lack of understanding, lack of knowledge on the part of the oncology community and physicians in general that think that fasting and low carbohydrate diets that cause weight loss makes the patient sick. It's therapeutic weight loss, not pathological weight loss. So at the very beginning, you have a little bit of an overlap. You have the cachexia coming from the tumor cells, and then you have the loss of weight coming because I'm restricting the glucose. So as I restrict the glucose, naturally, the damn tumor cells are going to die. So the tumor cells causing the cachexia are dropping out, and they eventually become lower and lower. And then you say, "Oh, I lost all this weight." But how do you? "Oh, I'm starting to feel a hell of a lot better." "Oh, what's going on?" And then all of a sudden you start eating some brain broth, you start having low carb diets, patient starts gaining weight, and where's the cancer? I don't know what happened to the cancer. So again, you have to know how the body works. You have to know what's the mechanism for weight loss. Is it pathological? The other thing that's very interesting is in cachexia, when you water-only fast or do low carbohydrate diets, insulin levels go low, glucose goes low, ketones go up. When you have cancer cachexia, insulin levels are high.
Wow.
This is unbelievable. It's just the opposite of what you would say. This is pathological. This is not normal. So you just have to know how to play these cells. You just got to know the biology of the body. That's it.
Yeah. I mean, but I feel like for your average, is it not risky for your average person who's, naive to strict dietary modification? I mean, the ketogenic diet is known as being one of the most difficult diets to adhere
that's
to.
Bullshit. That's bullshit. These people don't know what the hell. What are they doing? Eating a tub of lard? Biting off sticks of butter? I mean, this is nuts. You can eat ribeye steaks with a nice egg on top of it. I mean, what's wrong with that? You can eat vegetables that are low glycemic vegetables that release sugar very low glycemic vegetables. You can eat avocados. You can eat a lot of things. In fact, colleagues of mine are developing really very, very palatable, delicious keto type diets. When I say ketogenic diet or therapeutic ketosis, all it means is low blood sugar, elevated ketones. You can do that by eating salmon. You can eat a lot of things that are not low carbohydrate stuff will bring you into a state of ketosis. And that's like a ketogenic diet because the ultimate goal is low glucose, elevate ketones. How can I get in there? Can I do it as a vegan? Can I do it as a vegetarian? Can I do it as a carnivore? And the answer is you can do it in any of these as long as you can get that. And I have a meter, the Keto Mojo meter, will tell you whether you're in ketosis or not. So people can mix and match a lot of different things. It's only considered unpalatable to the people who don't know things. So, they were told, oh, that's bad stuff, man. That's bad stuff. Well, I don't know. I eat ribeyes. I like a ribeye, right? Put melted butter on top of that. A little salt and pepper on top of that. You can't tell me that's not good.
That sounds like heaven to me. We gotta.
Me too.
Yeah. In fact,
maybe not to the vegan.
No.
But he can go on a stick of celery or something.
That would be a huge mistake. No pun intended.
So it's not that. So we're throwing out a lot of misinformation about these things. That's the key.
No, I love this. Okay, so what I'm gathering is that a ketogenic diet, in your view, is potentially a very efficacious therapeutic diet.
Well, let's call it a diet that lowers blood sugar and elevates ketones.
It also has been shown to help boost efficacy of treatment, has it not?
Oh yeah. It can work synergistically. This is our colleagues in Istanbul, where they use the lowest levels of chemo that are allowable. There's a range at which you can give patients chemo. Most of the time in this country, we give them higher doses. Makes them sick as a dog. Patients, many of them, not always. There's always some guy out there who you can give him 50% of his body weight in chemo and he doesn't get sick. There's always some of those guys out there. But a lot of people get really, really sick. But if your patient is in nutritional ketosis, whether it's water-only fasting or keto metabolic therapy, you can give them lower doses of the drug because the tumor cells are already stressed out. So you don't need much to push them over they're a very weak, inefficient kind of a cell. They're already on the precipice of dying anyway. Wow. So you're going to just push them over the edge with a low dose chemo when the body is in nutritional ketosis, and you get more bang for your buck. You don't have to suffer from the toxicity. Yet you're going to be slaughtering these tumor cells.
It reduces the minimal effective dose of the medicine that's required.
Yeah, we can lower the dose down to the lowest level, and then you can reduce and you increase the efficacy. You'll kill more tumor cells with less toxicity to the body.
Wow, because it's like compounding stress to the tumor cell.
Yeah, absolutely. That's absolutely. One is a nutritional stress, and the other was a chemical stress, and together they blast the crap out of these tumor cells.
Fascinating. So as a therapeutic diet, I mean, this is super, super empowering information, but that doesn't mean that everybody has to be in ketosis to prevent cancer, right?
No, of course not. But all I can say is that our Aboriginal friends were always in some level of ketosis, and they never got cancer. But that doesn't necessarily mean that, we evolved as a feast-famine kind of a species. We enjoyed the feast because we were always half-starved. As a species, we were always in a half-starved state for eons. We came about about 1 million years ago, I guess you can say, that we started to have characteristics of some of the things we do today. So our ancestors before us as a species, it was a harsh environment to live. You have to live in ice ages. You're always in a semi-starved state. So when you have a feast, you're going to eat a lot of. What are you going to eat in a Paleolithic feast? A whole bear, a whole elk. You're not going to have a big Dunkin' Donut after you finish eating the elk.
No.
Big cake. Now I think today we're always in a feast. We're living, every meal that we have is like a feast, a massive amount of calories. And it's just so against our past, our evolutionary past.
Literally foods that perpetuate their own overconsumption.
Yes. Oh, absolutely designed to be so delicious. I told people, like I had McDonald's hamburgers. I mean, I had one for the first time last year in about 5 years. I stopped with the kids needed something to eat. Everybody's yelling, "Let's get a McDonald's." I got a quarter pounder with cheese and some fries with it. It was so damn good. I was trembling while I was eating the damn thing. I said, "Holy Christ! I mean, this is." I said, "Oh, I'm going to die for 1 hour while I eat this thing." But it was delicious. Absolutely delicious.
Oh yeah, I remember. I mean, I haven't had a McDonald's hamburger in decades, literally.
Try one. Try
But yeah,
one.
no, they're delectable. They're amazing.
It is delicious. It's unbelievable.
Yeah. So eat minimally processed whole foods that are going to fill you up, that are high that are satiating, that are not going to drive their own overconsumption. So if you could describe a cancer prevention diet for us, what might that look like?
Well, I think it would be any diet it's not only cancer diet, it's also the exercise that is extremely important. Daily exercise as best you can, and a diet that is of natural nutrition as best you can. Plants that are naturally grown, not GMO kinds of plants, genetically modified things. Things that are. You look at a tomato that looks just really delicious, but it's been sitting on the shelf for like 6 months. Obviously there's something wrong with that tomato. Tomatoes shouldn't look good 6 months. Natural stuff will degrade. I have a box of Twinkies up here. You got to love this, right? Twinkies. I use it as
I can't wait to see this.
I use it as a prop for my class, right? You know what a Twinkie is, right? Can you see
of course. I grew up eating them, yeah.
Okay, I bought these Twinkies in 2010.
No way.
Yeah, look at it. Looks just like it's brand new.
It's in perfect shape.
Perfect shape.
Insane.
It's like synthetic. Now, I use it as a prop for my class, and we read the ingredients on it. You have to have a degree in biochemistry to just read the ingredients on this thing.
There you go.
It looks great, right? Look at this beautiful Twinkie. It looks almost ready to eat. I mean, it's a little hard, a little stale. It's been in there for over 10 years. But I had a mouse broke into my office last year. He got up on that shelf and he got into the box. He broke through the plastic and ate one of these things.
No way.
So apparently he wasn't concerned that it was 10 years old. So,
wow.
But I'm telling you, it's unbelievable. So this is not what we call a highly nutritious piece of food.
Definitely not.
But you go down in the supermarket shelves. I mean, you look at the backs of the box. They got high fructose corn syrup, a lot of carbohydrates, a lot of stuff that's not natural. That's why it has long shelf life. Things that are natural don't have long shelf lives. They naturally break down. But these synthetic stuff, man, and you eat that, and it has a lot of carbohydrates in it, which are poorly nutritious. So our bodies love carbs. And the genes, it's not the genes evolved to store energy. You give the body energy, it's going to store it.
Yeah.
So you don't blame your genes. You're here today because of those genes. If those genes did not allow you to store energy, there was no way you have to worry about Ozempic, or any of these kinds of crazy things that people are taking. But as a species, we like the easy way out. We always like the easy way out. I mean, I don't want to diet, and I can shoot myself up with this drug and lose the amount of weight. I'm going to go that. We have long stairs here at Boston College. You have to walk up a large number of stairs to get from lower campus to upper campus. And then we have a building right next to the stairs where there's an elevator. And you can't believe all these young kids, they pile in the elevator rather than wanting to walk up the stairs. Some kids do. I mean, everybody likes the easy way. So if there's an easier way to do something, we're going to do it. And a pill that will allow you to eat whatever you want to eat, and I don't have to restrict anything. That's the way a lot of people will do that. Another thing we've noticed is that, people say, "Oh, I want to do this metabolic stuff," and we find out that we're looking at some people. They do get beautiful low glucose, elevated ketones. They're really disciplined, and then we find some people it never works. It never goes down. And so, what is going on with these people? Why is that? Then we find out they're cheating. They're cheating on themselves just to make someone look like, but the numbers tell you, I'm of a particular background. I never get low glucose. And then they find the guy's cheating on himself. This is what people will do, so it's just human nature, behavior.
It's tragic. What about the notion of cancer-fighting foods? Are there any cancer-fighting foods out there?
Well, that's a good point. There was a study that was done with New World monkeys. I can't remember the species. They rubbed a chemical tar and chemical carcinogens on the skin of these monkeys for 10 years. And they injected the monkeys with these chemical carcinogens and never got a cancer for 10 years and then they concluded monkeys are a bad model for cancer. This species of monkey was a bad model. So the monkeys were eating their natural diet of plants and whatever they were on their stable diet. And that was powerfully preventative for even us when we were on our natural diets of organic meats, organic berries, organic things. Our species does not get cancer. Whatever the Eskimos, the Inuits, or whatever you want to call them, they were eating natural foods. They never got cancer. Now they're riddled with cancer when they got off their diet. So provocative agents like chemical carcinogens, smoking, and all these kinds of things, together with the abnormal diet, put you at tremendous risk for getting cancer. So the answer is yes. Natural diets, the way we evolved, are strongly resistant to developing cancer. The problem is we're no longer on those diets. We're on Twinkies, and or some similar thing, and next thing you know, you got cancer because you've taken these immune, natural, resistant processes away from us, putting at risk for damaging respiration and the origin of cancer.
Well, you and I, we live in the United States. As far as I can see across the webcam, you're not living in an Inuit hut. You're in Boston. I live in Los Angeles. So what are the kinds of foods then that we should be eating on a daily basis?
Well, I think
describe that dietary pattern for me.
Those dietary foods are rare. Big agricultural industry provides the foods that we have on the supermarket shelves in large part. Organic farming is a natural way, but there's no. My former professor Herman Brockman, when I did my degree in genetics at Illinois State University, runs a pure organic farm where there's no chemicals at all. They handpick the bugs off the plants and they feed them to the chickens that are free range. Everything is absolutely organic. And when you eat that food, man, I tell you, it's the most delicious stuff you've ever had. So they pack it up once a week, put it in a big truck, and they drive it to Evanston, Illinois, where people wait at 4 o'clock in the morning for the truck to come. And by 9 o'clock in the morning, it's completely gone. All the food is gone. But, that's organic farming for people that understand it. We have so many people in this country that could never afford that. It's expensive. It's not cheap to eat organic food. You have to wait for it. You have to eat it right away because it's going to spoil on you because it's not chemically fortified. So that's the natural diets, those kinds of things. And they raise free-range cows and this kind of thing. And all that is quite natural. And free-range meat is much tougher than the corn-fed. I didn't know the difference between grass-fed and corn-fed until Dr. Brockman told me. He says, when you say corn-fed, everybody says, got to have corn-fed beef. Corn-fed beef is really tender and delicious, whereas free-range beef is much more chewy, gamey flavor. I said, how is corn? He said, cow did not evolve to eat corn. Cows eat grass. They don't eat corn. So you feed a lot of corn to a cow, and it gets massive amounts of acid indigestion, burping and everything. And then you give them a whole bunch of antacids. And the antacids working with the acidification makes the meat really tender.
Ooh, interesting.
Let's go to Morgan Steakhouse and get some of that. Some of these Ruth Chris's meat. Maybe have a Ruth Chris's steak. Man, it's the most delicious thing.
I ate there the other night. You're not wrong.
It's delicious, right? It's unbelievable.
Yeah,
but you got to pay like $50 or $60 for a steak.
Oh, it's expensive. It's expensive. Yeah, I try to eat grass-fed, grass-finished as much as I can.
Yeah, well, I'll tell you, if you do grass-fed, you might as sous vide it. What you do is you put it in a seal meal bag and heat it up gradually to a temperature like 129 rare. And then what happens is it breaks down the collagen in the meat with the warmth, and then you throw it on a grill, both sides, sear it, and you can get a much more tender meat. If you try to eat grass-fed, just throw it on a grill for two couple. You're chewing. Got to file your teeth down to cut through that meat.
It can be a bit tougher, but man, you're making my mouth water. Okay, so you brought up the subject of meat, so I have to ask. You are one of the world's preeminent cancer experts. Does red meat cause cancer?
What causes cancer is damage to oxidative phosphorylation. So can eating red meat damage the mitochondria in a particular population of cells? I assume if the meat is loaded with chemical carcinogens, it might be a provocative agent. But I can't see how we evolved to eat red meat. I mean, the Native Americans, the Plains Indians killed and ate buffalo. That was like, what the hell? Did they think they were worried about colon cancer to eat the goddamn buffalo? I mean, we evolved as a species to eat red meat. I mean, we killed elephants. We killed anything that walked or crawled, we'd eat it. So the question is, are you eating healthy red meat or treated red meat? With the nitrites and, preserved red meat or something along those lines where you'd have a lot of chemicals in there. That might not be the healthiest thing for you. But if you're eating natural red meat, what the hell? I mean, we evolved. You and I wouldn't have this conversation if we weren't able to eat red meat.
No, I'm with you. I'm a big advocate for omnivory. I eat red meat very often, and I feel great, and my labs are all great, and I have no problem eating it, and I think I also think it's a health food. But on this podcast, I love to play devil's advocate, even to my own biases.
Yeah, and, I don't know. You can Anthony Chaffee. Look at him, Claffey. He's from Australia, American. He's the big carnivore guy. I did the podcast on his show. I mean, they only talk about how much beef they can eat and all this kind of stuff. He's a world expert on cooking tomahawk ribeyes. He'll show you exactly all the methods. That guy looks great. He looks like an Adonis. He says and plant never touches his lips. So I'm saying, well, what's going on with that? Then I have the vegan guys on the other side. Oh, I ate a piece of beef. I'm going to go to hell. It's going to be, it's like, oh, geez, I'm going to die, drop dead of a heart attack if I eat a piece of meat. We have the extremes in our society. I mean, we got nuts on both sides of the spectrum, no matter what you do. Politics, food, no matter what it is. You got, as I said, we're omnivores. We evolved to eat anything that crawl, walk, or fly, swim, whatever. Anything we can get into our mouth, we'd eat it. But in all those cases, they were all natural. They weren't like all processed that we have today. So we have a lot of processed foods that really are very, very tasty, that are probably very poorly nutritious, and they're doing harm to the body. And that puts us at risk for a lot of different things.
What are some of the more prominent carcinogens? You mentioned carcinogens early at the top, chemical exposures.
There's a mutagen carcinogen societies that look at chemicals like 3-methylcholanthrene. We use 3-methylcholanthrene as a chemical carcinogen to induce tumors. This is how we induce some of the brain tumors in mice. We use a lot of people used various chemical carcinogens to show that if you have that irritation in a particular organ over time, you can create and damage respiration, thereby contributing to the onset of cancer. In my book on cancer as a metabolic disease, I went back and I looked at a lot of these so-called carcinogens. And then it's very interesting, when you treat tissue with carcinogens, the mitochondria in the cell, they become fluorescent. They bioluminesce. They get a natural, telling us that the carcinogens are inside the mitochondria and they're causing damage. And wow. I told you can't get cancer if your mitochondria remain healthy. So the carcinogens damaging mitochondria force that cell now to switch to a fermentation mechanism over time. You don't usually get cancer by exposing to a chemical carcinogen. Like today, as I said, I'm exposed to a chemical carcinogen. Tomorrow I wake up with a big tumor. No. It takes a long time for the irritation and damage of that carcinogen to disrupt oxidative phosphorylation in the cell to switch it over to a fermentation mechanism. But the origin came from the carcinogen damaging the respiration in the cell.
And where do these carcinogens come from? I mean, we
we
obviously live.
Yeah, forever chemicals.
Yes.
I mean, a lot of the plastic industry, a lot of our industries produce a lot of carcinogens. I mean, they try to do a good job in cleaning it up, and they try to do this kind of, but the train loaded with the carcinogens falls off the track, and you got an environmental disaster.
Like what happened in Ohio recently, right?
Yeah, that's the big one in Ohio. And then they had the Love Canal in New York, I think. And then they had the General Electric dumping all the carcinogens into the Hudson River. And a lot of these folks had permits from the government to do all this kind of crazy stuff. And then only later on do you find out it causes an environmental disaster. But, there's a large amounts of chemicals dumped into the environment, which then can create a chronic. And you put that together with a bad diet and a lifestyle, and then you have the synergistic interactive effect of the carcinogen with the other aspects. Like as I said, very hard to get cancer. I mean, you really got to abuse the crap out of your body to get cancer, because we evolved to be totally resistant to cancer. I said from our Aboriginal ancestors, they rarely, living in their lifestyle natural, you don't get cancer. It's only when you put yourself in a totally different environment, exposed to chemicals, bad food, and all this other stuff, you put yourself at risk for all these chronic diseases.
But it seems like so many people today are suffering from cancer, right? Something like 2,000 people are dying every day from.
No, 1,000, over 1,600 people a day in the United States are dying. Yeah, but I just said, where's it coming from? Diet and lifestyle. I mean, look at the people. They often have, when we look at the cancer patients, they often have type 2 diabetes. A lot of them are overweight. A lot of them have all kinds of other issues. Besides they have cancer. Now, there are some people that are thin that have cancer. They don't have diabetes, and they don't have, and those folks, their body may be more resistant to certain obvious things like obesity and things like that. But everybody who has cancer has damage to the oxidative phosphorylation. So when Albert Schweitzer, the great humanitarian physician, went into the jungles of Africa, they looked at 40,000 people over several years, and they never found one guy with cancer. So they had all different body sizes, shapes, and everything, but no one had cancer. So what's going on? Those folks are living in the way they evolved, in their natural environments. So clearly, cancer comes as us moving from an environment in which we evolved to an environment which was created by our industrialized societies.
So even if you're normal weight, I mean, we do know that a significant proportion of people who are normal weight are still metabolically obese.
Or metabolically imbalanced. Even the thin guy could be metabolically imbalanced. So it's or not exercising. Exercise is a way to get oxygen into the system, keep your mitochondria healthy. Skip a few meals and walk 2 miles, 3 miles a day. And all of a sudden, and that's another thing too, this water-only fasting that people do for several days or a week. And I published it on our dog paper. You got to read the dog paper. It's beautiful. The dog had a big tumor on his face, a mast cell tumor. And a woman it's all written out there. She put the dog on a carnivore wolf kind of diet, like raw meat, raw egg, fish oil. And this tumor completely disappeared. But the dog was only given small amounts of food. And what I published in my book is the process called autolytic cannibalism. So
what is
when
that?
you restrict, that's self-eating. So it's like autophagy. Autophagy is a type of self-eating. But autophagy involves the reconfiguration of organelles within a cell, a single cell. A mitochondrion that doesn't completely work can be consumed by the lysosome, and the particles of the mitochondria can be redistributed or some other organelle. Autolytic cannibalism is where you would have a growth, a cancer, say, a growth of cells. These cells are inefficient in their metabolism. So like I said, when the whole body now becomes restricted, you're competing against the cancer cells are now competing against the normal cells. And the body has a surveillance system. So it sees these cells that are not carrying the weight and performing the way they normally would. They attack them, dissolve them, and then release the fuel from those cells back into the bloodstream, and the normal cells take it up. And this is called autolytic cannibalism. And that can also, we have people that do these long fasts, like 21 days or something like this, and many of them have cancer, and it completely goes away. The body turns on the tumor cell, uses it for fuel for the rest of the body.
Fascinating. So what happened? So in the case of this dog, the dog was put on like this carnivore diet. The tumor went away?
Yeah, in about 3 months. The pictures are in there. So it was a pit bull. It's published. We published it in the Journal of Oncology of Nutrition. Where is it? Yeah, it's so anyway, big tumor. The woman thought that when the tumor was first diagnosed, it was a mast cell on the lip. The dogs die. A lot of mast cell tumors, very common tumor in the dog. That she didn't want radiation, chemo. She didn't want any of that stuff. So she gave the dog a vegetable diet, raw vegetables with lentils and a cooked piece of fish.
Oh, that poor dog.
The tumor got bigger. So the tumor started to grow bigger. And then she listened to my podcasts, she's no scientific background at all. She just listened to what we did with the mice. I published what we did with the mice. She did the same thing with her dog. And within a few months, the damn tumor just shrunk up and went away. And it's autolytic cannibal. I said the mechanism is there. And the dog was a pit bull. It was 7 years old when the tumor was first detected. It grew bigger for 2 years. A dog at 9 years old, she finally put it on this carnivore diet, calorie restricted carnivore keto diet. And within 3 months, the tumor went away. The dog died of old age at 15 years of age from heart failure, which lived longer than the normal pit bull dogs mostly live. So in comparable age, it was a 105-year-old human.
Wow.
So cancer never recurred. And the dog died from old age from heart failure rather than a recurrence of the tumor. So that's our only absolute convincing case of a cancer cure, because the only way you can know you cure cancer is if you die from old age from something other than the cancer. So otherwise, you never know whether you're cured or not. Oh, I'm having cancer. It hasn't recurred in 5 years. 6 years, all of a sudden, it comes back. Well, you weren't cured. You were just in a suspended state for 6 years. If you die at 98 years old and the cancer doesn't come back, then you know you were cured.
Well, is there ever a point at which it's too late? I mean, as the cancer progresses and you enter these
what I find
more advanced stages.
Yeah, the too late is when a person takes no therapy whatsoever, and they present with like metastasis everywhere in their body, and they can't breathe. They're really on death's doorstep. That means somebody who's just done nothing for that. The other thing that happens is when the cancers are treated over and over again with toxic chemicals and radiation and this kind of stuff, and the person says the cancer has recurred. Well, now your healthy cells are been beat to hell by poisons and radiation and all this kind of crazy stuff. And you make the body weak, and you free up a lot, and eat Infamil drinks and ice cream and candy, and you just create a situation where you reduced, the cancer cell is in charge. Your body has been beat to hell. So you're really killed by the treatments rather than the cancer. The cancer is there. You just reduce the competition. So there's a lot of things. A lot of people dying from the treatments. The cancer treatments, when they say die from complications, it could be, there's a lot of things. I've spoken to a number of cancer physicians. They think 50% of their patients that die from cancer die from the treatments. So, I mean, you tell me another affliction where you have to be poisoned and irradiated to make yourself healthy. It makes no sense. I tried some of these chemicals, cisplatin, carboplatin, and these things on my mice. The mice, I never saw an animal get so sick and fast in my life. I can't believe that a human being would take that same stuff into its body and think it's going to work. And sometimes, remarkably, it works. We have thousands and thousands of cancer survivors that have survived radiation and chemo and every kind of a thing they could throw at you. But a lot of those people are sick in a lot of different ways. They have all kinds of hormonal imbalances, neuropsychiatric problems, digestive problems. They get all kinds of surgical mutilations. They have immune system problems. I mean, obviously, I mean, take it. You want to volunteer? What's your big cancer center out there in LA? You know what it is?
Cedar Sinai. I don't know.
Yeah, go to Cedar
Sinai.
Sinai. Sign up and say, I want your best cancer therapy.
No, thank you.
No, we're going to give you a cocktail of carboplatin, cisplatin, and then we'll just spot radiate different parts of your body and see in 3 weeks how you're going to feel.
Wow.
Not good, right? Yet we have somebody with cancer and we do that to them. You tell me what's the logic of that.
No, it's terrible. My mother actually passed due to pancreatic cancer, but she had dementia for 8 years prior to that. And her cancer was, but when they detected it, it had already metastasized. There was evidence of that.
Yeah.
And because her performance status was so low, she was not even a candidate for treatment.
Yeah. Yeah.
And so,
well, pancreatic cancer is a tough nut. It's like glioblastoma. It hits you hard before you even know you have it. It's already well developed. But it's, again, every pancreatic cancer cell and tissue that we've looked at, they have damaged mitochondria and they're fermenting. So clearly they're going to be vulnerable to that kind of approach. But nobody's doing that. And there's no clinic anywhere except some of the ones we know in different places where they recognize that, where they would simultaneously go after glucose and glutamine while putting the body in nutritional ketosis. That's going to be the solution to the cancer problem. Because once you do that, the results are going to be spectacular. And we already know that. I published these case reports. I mean, we had this liver, what's this one here? Restricted ketogenic diet therapy for metastatic lung cancer. This guy had lung cancer he's a Greek. He had lung cancer that went to his brain and other organs. And my colleague, Dr. Athanasios Evangelio, he understood what I was saying. And he said, well, we're going to put this guy in a restricted metabolic design. And he wasn't responding to standard of care. All of a sudden, he makes a dramatic response. He's still out 9 years. This was, when you have cancer that goes from your lung to your brain, you don't usually have very long to live. This guy's alive 9 years. So,
oh my God!
And we have breast cancer woman. We have a number of these folks that are avoiding with terminal. They all these guys had terminal cancer that turned out not to be so terminal. Wow. So it can work if you do it the right way. You have to have knowledgeable people doing this. The patient needs to know about it and be compliant, and the oncologist needs to know about it and has to monitor all these different parameters. And then you're going to see results that you have never expected to be possible.
Wow, this is so fascinating and so empowering. If I, or God forbid, anybody else that I love, ever develops cancer, anybody listening to this, I mean, I feel like you're offering such powerful and important information. I want to touch on exercise because you've mentioned it a few times. Is there one form of exercise that's better than another when it comes to cancer prevention, or are they all sort of on equal playing field?
Well, I think one has to be like, to prevent cancer. I think anything you do, any movement is good. Lifting weights, isometric exercises, cardiovascular exercises. You do a range of things when you're young. And, you can do all that. As you get older, obviously, you get arthritis and you get things that'll prevent a little bit more. But whatever it is, swimming, walking, biking, the issue, of course, is once you develop cancer, some people go out and they start like running marathons and they go to the gym, lift all this weights. You're going to create some level of systemic inflammation by doing all that. And you want to try to avoid systemic inflammation. So cardiovascular exercise may be better, soft, maybe swimming, walking, maybe small jogging, not any really competitive type of exercise, only to keep inflammation down. So, but anything cardiovascular is going to bring oxygen, it's going to make your normal cells healthier. You get into a low range of ketosis with some exercise, and the normal cells get super healthy. In other words, you're increasing the health and vitality of the normal cells, which will be needed to compete against the tumor cells. So again, it's the strategy of knowing what to do and how to do it.
Well, yeah. I mean, if I may, like resistance training acutely might cause some degree of inflammatory markers to see an elevation. But I think over the long term, you end up seeing a reduction. I think, and also from a metabolic health standpoint, I think resistance training, just from my own, research and experience, seems to be, incredibly important, and also for the population.
Yeah, it is. I'm not saying there's resistance if you don't have cancer. So resistance training is really extremely important. But if you were to have cancer, and you want to avoid increasing more inflammation in the body, then you would have to do an exercise that would maintain lower inflammation. But if you're healthy, those inflammatory elevations from resistant training, your body will adapt and adjust to all that, and you're not worrying about driving or creating an environment that would be facilitatory towards the survival of a tumor cell. You're talking about prevention now. This is a very different thing than if you have the tumor.
But even if you have the tumor, building muscle, your skeletal muscle serves many purposes. One of which being, glucose disposal, right?
Look. Yes, you lift weights. Yes, you do. But you don't do it in Olympic style lifting weights where you got to break some sort of I got to lift 200 pounds or I'm going to be dead. No. You know what I'm talking about. We go to extremes. Okay. Instead of lifting 75-pound dumbbells 30 times, lift a 20-pound dumbbell. just don't do it so much. It's the excessiveness of what I'm saying. I'm not saying don't do resistant training. I'm just saying don't do anything so excessively that you're going to create stress on the body that is going to in any way prevent your normal cells from becoming as strong and healthy as they possibly can.
Yeah, too much of a good thing in any scenario can become.
It's obvious.
Yeah. Can become a bad thing. What about something that I want to bring up? I don't know if you have strong feelings on this or not, but we hear a lot about refined, bleached, and deodorized seed oils now in the standard American diet in the food supply.
I don't know what to say. I haven't done any seed oil stuff. Our mice have what they call terminal cancer. Our preclinical studies. Terminal cancer. And our goal is to eliminate the terminal cancer. So I'm not, when I'm feeding seed oils to mice and find out, does it make the tumor worse? We can do a lot of things. Some guys down at the Weill Cornell Cancer Center were feeding the mice K-Ro syrup. What is it? High fructose corn syrup. Okay, well, you can make your tumor worse doing that, but can you wait? If I have cancer, do you want me to chug a bottle of seed oils to see if I can get it to grow faster? It's like, what the hell? Who's going to do something like that? You got to use common sense, right? If some guy says, I got a metastatic lung cancer, they're talking about that seed oil. They say it might not be good. Well, let me chug this bottle of seed oil, see if I can make that tumor worse. Right? Who's going to do something like that? You'd be surprised. There's actually people that will do that.
Well,
I can't talk about seed oils. Did you get cancer because you consumed too many seed oils? I don't know. So what are you going to do if you get cancer? You're going to drink more seed oil? You're going to eat less seed oil? I don't know. It's like, give me a break. It's just, there's certain things we know that tumor can't live without glucose and glutamine. Let's focus on that.
Right. Fair. I think it comes, sometimes because of the chemical instability, like the unstable nature of these polyunsaturated fats when stripped from their whole food, and the heating and the repeated heating, particularly in the fried food setting, they become there's the thinking that they become pernicious because of the creation of like all these oxidative byproducts. Acrolein, I know, is generated.
Well, I think if you have a BMI of 35 and you're sitting there eating 4 pounds of French fries and fried chicken, you might want to reconsider what you're doing.
There you go.
Right. Makes sense, right?
Yeah.
In that guy's case, he might have something to really worry about. But every now and then you can eat a piece of fried chicken. It's not going to kill you. But it's just how often you eat it, how much you eat. It's probably more likely to be a problem.
The dose makes the poison.
Yeah.
Yeah. You touched on plastic a little bit. Would you say that it's probably worthwhile as part of a holistic cancer prevention strategy to minimize your exposure to plastic and plastic-related
how do
compounds?
we do that? Plastic is everywhere.
It is everywhere.
It's everywhere. Let's be honest. It's in water bottles. It's in grocery store bags. It's like I mean, my God, where you going to go to find a place there's no plastic? Even in the ocean is full of plastic. I mean, they got a big thing. They got an island of plastic in the Pacific Ocean. It's like bigger than California. It's like, what the hell? They all got these animals living in the plastic too. They got a new types of animals loving the plastic islands in the middle of the Pacific. And they don't seem to be worrying about plastic. But the issue is that, yes, plastic is an environmental contaminant. How dangerous is it to us? Yes, it's dangerous. If it gets into our bodies, we can't break it down. Okay, we found pieces of plastic. Here in Massachusetts, we have Wellfleet oysters. It's like really good. You can go out in California, get Wellfleet oysters. They're delicious, right?
I love oysters.
We have a guy down the hall here who analyzed these oysters and found minuscule pieces of plastic in the damn oysters. So it's like it's in our ecosystem. Well, the oysters are filter feeders. They're in the water. Somebody throws a plastic bottle and plastic shit into the ocean. I mean, these filter feeders are going to get it, right? So it's in our environment. It's there. Is it good to have it there? No, it's not good to have it there. We have another person in our department who identified plastics as being a real contaminant, a real problem in the environment, and they interviewed the plastic industry, and we're doing everything we can to prevent this from escaping. We're not really concerned about it, but it's everywhere. So it's another part of our environment. Okay, we're living in somewhat of a toxic environment. So even with that, we those are provocative agents with the appropriate diet, with the inappropriate diet and lifestyle, and then you have these chemical carcinogens in the environment, puts us at risk for all this stuff.
But what I'm hearing from you is that we can stack the odds to some degree in our favor by eating a healthful diet, eating a diet that is more akin to the type of diet that our ancestors may have consumed.
Yes, absolutely. So you can reduce risk. Yeah, that's all you can do. You can reduce the risk of putting yourself. But we have an obesity epidemic. Obesity puts us at risk for cancer. How is it possible that we would have so many obese people? You think they give a crap about what? I mean, obviously they're not worried about it. If they were, they wouldn't be so many fat people in the society. Fat makes your increase your risk for cancer. Well, obviously it's not impacting anybody. Even the little kids are getting fat now, and what's going on with that? They're going to have a reduced lifespan. So apparently somebody doesn't care or is not aware of what's happening, or they're blaming it on their genes. Not the fact that my mouth doesn't work. I got to blame it on my genes. Or blame it on somebody. Blame it on the industry. Blame it on this. Blame it on yourself. You're the one putting yourself at risk. And we have to be also aware that there are some folks who are trapped in these food deserts and they don't have the opportunity as other people do. So they're really trapped and they have no other option. So I feel bad for those folks because they're the ones who are going to be most at risk for these kinds of conditions, and through no fault of their own. In those cases, they just happen to be in an environment that's going to make their life a little bit more difficult. So we have to recognize that.
Well, on this podcast, I mean, we've done so many episodes about how to lose fat, how to shift your body composition to a healthier state. So I think it's important to note that the lowest hanging fruit that we've revealed here is that you should, if you're overweight, if you're obese, that should be priority number one, right? To not be overweight.
Well, the thing of it is that yes, that's true. You can't get overweight. The only way to get overweight is to eat. You can't, there's no other way that I know that people can put on weight on their body unless they eat, right? I don't know if people, so the problem is that, but you're blaming it on something else for a lot of people. In fact, the government came out and said obesity is a disease. What do you mean it's a disease? It's not a disease. It's a disease of can't keep your mouth shut. That's the disease. So, but God forbid we might offend somebody by saying that. But that's the fact. I don't know anybody who got fat without eating.
Well, there's a joke. Person A says obesity runs in my family. Person B says, "Are you kidding? Nobody runs in your family."
well, that's true. So, but the problem is now, we're going to invest massive amounts of money in drugs to see whether we'll allow the person to eat as much as he wants all the time, but we're going to give him this drug. And the only way to make him not eat is make him feel like I'm full. That's what bariatric surgery does. I mean, you take your stomach that was the size of a basketball, and now you make it the size of a walnut, and I can't. I took 2 bites or whatever. I'm full. Okay, then all of a sudden you start losing massive amounts of weight over a very short period of time. But some of those folks put it back on again because they never really addressed. The stomach starts to expand again, and you start getting fat again because you never addressed the problem in the first place, which was overeating or eating too much or not having discipline, know what's good or what's not good. It's hard. The brain is wired. We become addicted to glucose. Glucose is like a drug. It's like trying to give up alcohol or cigarettes or something like this. It's not easy. I don't want to make this out to sound like this is a simple thing. Just stop eating. You are already addicted by a molecule called glucose, which is present in these kinds of foods here that make you addicted. And it makes it much harder to stop eating because it's like a drug. It's like cocaine. It's like opium. The pleasure of eating something sweet is just, we evolved to love sweet things. So again, it's in our genetic background to want this. And the industry is making it very, very easy to get it, cheap, and there it is. And it's going to be very tough, very tough.
Yeah, another underappreciated issue with these weight loss drugs is that unless you instill healthy habits and you start exercising and you shift the composition of the foods that you're eating, you end up losing a lot of muscle in the process.
Yeah.
Unless you're resistance training, like anybody who goes on a reduced calorie diet, unless you're resistance training and you're keeping your protein at a sufficient threshold, right? You can't just eat less of everything that the obesogenic food that you're already eating.
Well, that's one of the things that why keto diets and fasting. The last thing we do is dissolve muscle. You'll burn. The fat is there to replace energy, but to spare muscle. Muscle is an evolutionary necessity because and also the sugar in muscle is glycogen. There's long strips of glucose in there. The muscle does not share its energy with other organs. Okay, the liver can share because it stores glycogen, so that when you stop eating, the liver will release the sugar back into the bloodstream. But the muscle never shares. Why? Because you're out on a hunt, and all of a sudden, the hunted you become the hunted, and you got to run, and you got to get the hell out of there. And if muscle has no sugar, you're going to be the food of the guy that's chasing you. So you need to have that, or kill the guy that's trying to kill you. So the muscle, it's all evolution. If people don't understand evolutionary biology, they're lost. Everything is designed over millions of years to do things, and that's the thing. So muscle needs energy for itself. You want to spare. If you want to lose weight, you want to lose fat. You don't want to lose muscle. So You always have to be, that's why when you're on weight loss, you should be exercising, keep the muscles strong, lose the weight, and you'll be back in normal shape again.
Absolutely. What about alcohol? What are your thoughts on alcohol? This is I feel like it's very trendy these days. A lot of people are giving up alcohol. They're relinquishing the bottle. Because I feel like the data that I've seen, or at least the headlines that seem to make it onto everybody's front page, is that decades of research overturned. Moderate drinking is no longer considered good for you. It's a known carcinogen. What are your thoughts on booze?
Well, I don't know. I just go down to Boston during a Red Sox game. Apparently, those people never heard about that. Boston Bruins Celtics game. I mean, the bars are loaded before the game. Let's be honest, right? I mean, every time the basketball player goes into the stands, he's knocking beer out of everybody's hand. So it's like anything. I guess there's moderation, and we're not going to go back. I mean, people like beer, people like wine, people like cocktails, right? I think I drink cocktails, I drink beer, I drink wine. All right. I mean, if somebody says you're going to die from cancer from drinking this, a glass of beer, I'll take my risk. I'm not going to say that. I mean, But if you're drunk every night, you're crawling around, can't find out where the bathroom is, you may have a problem. You know, it's like anything. I think if you do things in moderation, although let's be honest, human beings are not most. Do you ever find a real moderate guy? I mean, this guy, I only have 2 wines every day. I only eat 3 bites of this. I exercise just enough to get me. I never see guys like that. They're always like massively doing something. You know, I'm sure there's a few moderates out there, but they're not as many as the impulsive kinds of people.
Yeah, that's kind of my thinking is that somebody who's able to moderate their consumption of something that is generally considered to be very pleasurable, whether it's alcohol or ice cream or junk foods, you know, you might see a signal at least in the observational literature, and I haven't validated this, but that like it's the capacity to be moderate that is actually what is causally creating the good health outcomes that we see.
I think so. Discipline and moderation. I mean, but those properties are not
pretty hard to come by these days.
I think so, you know. But that's getting a little off topic. We're working on managing cancer, and that's our main focus. And all these other things are, you know, facilitators or interferers or whatever. But the idea is like when you have terminal, supposedly stage 4 cancer, and you can live longer. By managing it through a very strict drug diet combo, press pulse therapeutic strategy, I think you have a better chance of longer term survival with a higher quality of life than you might have if you chose a different direction. So I think that's what we should always keep our focus on. It's an epidemic of cancer. It's killing over 1,700 people a day, and it's causing tremendous harm and pain to families all over the world. And I think that does not have to happen. And I think that we could easily reduce this death rate by 50% in 5 to 7 years if we were to do what we know should be the right path. And I think we have to keep our laser focused on that. I mean, these other issues are certainly important and worthy of discussion. But the issue is the person that has the stage 4 cancer now can't worry about what he should have done, what he did, and all this stuff. His time on the planet is limited, and you want to make sure that person can extend as much time from her life as well as possible with a quality of life, and that's the focus that we have. And our success is this guy with the lung cancer, the guy with the brain cancer, the woman with the breast cancer, all terminal people that are living far beyond what they would have been predicted had they chosen a different path. And I think we have to keep that in mind all the time. And that's why I don't speak about a lot of these things other than off the cuff. But we're laser focused on improving survival with cancer. Our funding comes predominantly from private foundations and philanthropy. So I don't get money from the federal government to do this research. So we have a lot of people that wanted to be part of this new momentum of managing cancer using the science that we know should be there at the forefront. Developing diet drug combinations that will allow people to manage their cancer without toxicity. This is the future. The press pulse metabolic therapy will eventually, I don't know how long, will eventually replace all of the crazy things that we're doing to these cancer patients today. What we're doing today with toxic chemicals, immunotherapies, all these kinds of crazy things, they're all based on the somatic mutation theory, and essentially they're medieval in the way they treat people. So we're trying to eliminate that and bring the field back to where it should be. Cancer is a metabolic disease that can be managed with the appropriate drugs and diets that will degrade tumors slowly while enhancing the health and vitality of the body. So this is what we know can happen. It has to be a national will or an individual will to do that. And I think that's what the most important aspect of this whole thing is.
It's surprising to me that you couldn't get, I mean, some of the NIH like cancer budget, 0% of it is going towards your research and other researchers that are approaching this from a metabolic standpoint.
No, there's a lot of metabolic things, but it's under the guise that genes are controlling the metabolism. So cancer is a genetic disease. If you go to the National NCI website, National Cancer Institute website, go there. Have your viewers go there and see what it says.
Yeah.
Cancer is a genetic disease. What the hell am I talking about? I'm saying, no, it's not a genetic disease. It's a metabolic disease. You can't believe how many people are sequencing genes. As a matter of fact, when you take biopsies of tissue, you got that mutation, this mutation, it's irrelevant. That's what I'm talking about. So that kind of research is being, people think that's important. My cancer has the P53-1 mutation, the ALK gene mutation. It's irrelevant. Your cancer cell's fermenting. Take away the fermentation. When you kill the cancer, what difference does it make what mutations they have in there? So everybody's been led to believe that, my cancer be treated by this, and then they use poisons and radiation. Or immunotherapies. Immunotherapy, CAR-T, Keytruda, Opdivo, all those kinds of crazy things you hear about, they're all based on the somatic mutation theory of cancer. If cancer's not a genetic disease, why are you using that stuff? Well, it works on some people for sure, but it kills a lot, almost as many people on the other side. So what are you doing? It's not based on the scientific understanding of the disease. That's what my issue is. My issue is that why does not the field, and that's another big discussion, why the field will not go into this direction, because there are obviously other issues.
Yeah. Well, I thank you for your work as a family member of somebody who passed due to cancer. I mean, it's definitely affected my life, and I'm sure it's affected the lives of many people who've tuned in to listen to this. So thank you so much for your work, Dr. Seyfried. Yeah, well, thanks, Max. It's real good. And I, eventually people will come to know, and things will change. We cannot continue on the same path that we've been on for the last 50 or 60 years. How can we help? Well, I think the best way was people who want to support our research, they donate to Travis Christofferson's Foundation of Cancer Metabolic Therapy. He set up a foundation that supports a lot of our work. And a lot of people email me, and I send them a kit of information, and I give it to them free. But if the information in the kit helps them and their loved ones and whatever, I just ask them to feel free to make a donation to the Foundation for Cancer Metabolic Therapies if the information that I give them is helpful. So I'm not charging them I don't charge anybody for anything. I'm a professor at a university. I get paid from the university. I don't get paid for any of this stuff. So, but I do get research support to support the research that we're doing in the lab next door, developing diet drug therapies in the Press Pulse metabolic strategy. That's where people donate to the foundations. The foundation, through the university, supports our work. And then we can continue to do this. And I'm not controlled by anything other than the type of experiments that I want to run to see if I can keep people in preclinical systems alive longer. That's the bottom line. How long can you live with a terminal cancer in a healthy state? Hey, if you like that video, you need to check out this one here, and I'll see you there.
And we know that cortisol is really bad for glucose metabolism. So that's why we have two things. We have high melatonin. It's relatively high. It's not really peak, but it's still going down. And we have a cortisol peak, both of which are not good for glucose regulation.